3.
Oh, yeah.
What's up, guys? We're back at it with us, the lesson 5.1, period 7. Just like, let's go, ka-chow!
That was beautiful. So, everyone's notebooks are open. Everyone has a pencil in their hand. I even had pencil donations, so I do have extra pencils if anybody needs a pencil. We're not talking or making noises, okay?
Okay.
My goal for 2024 is to lead you guys in taking better notes. I tend to teach, talk, explain. But I don't take a lot of time to like, okay, let's write this on the board. Now everybody copy it down. I hope that you guys kind of write what I'm saying that would help you. But I know that some of you struggle with trying to figure out, well, do I write that down? She just said that, is that important? So I'm gonna try to take little snippets of the lesson to pause and say, let's write out the steps. I'll write them on the board, you write them in your notebook. That way your notes are very organized for when you have questions on homework, or we can use notes on a quiz or whatever.
I thought your goal would be to hit 1 million subscribers.
She's almost at
That
100.
is definitely not my goal, because
She's almost at 100. You're at 94.
isn't that amazing? But let's refocus.
I'm so sorry.
So, we're gonna take really good notes. The first thing we're gonna do is write the lesson at the top, lesson 5.1. It always says it at the top here. Topic 5, lesson 1, or lesson 5.1 is fine. And then we're gonna write the lesson name. Rational exponents and properties of exponents. What I love about algebra is there's almost no vocabulary for these lessons. But let's take a look at this one vocabulary word. Rational exponent. We've talked a lot about rational exponents over the past few days. Tell me what a rational exponent is. Yeah,
Isn't it an exponent that's a fraction?
that's exactly what it is. You read it? Okay, so it's our 2024 rule, okay? We're gonna do this. Ow!
That doesn't hurt. That does not hurt.
Uh-oh,
Can you do a high five?
Oh, that's gross.
uh-oh.
gosh.
Uh-oh.
Ruined.
Uh-oh. We need to get back on track, okay? We can't keep derailing. Anytime, it's okay to have like a quick funny thing, but it can't turn into a ripple effect of ridiculousness, okay? So, what we're going to be able to do by the end of this lesson is use properties of exponents. Can anybody condense what that really means, the properties of exponents? I like to condense it down to one word, a small word. It starts with an R.
Right, ration.
Nope.
Reciprocal?
Nope, it's a really small word.
Ratio.
The properties of exponents. The rules. We're gonna use the rules.
Oh, the rules.
We're gonna use the rules of exponents. Properties are just things about the exponents, and because of those certain things, you have to follow certain rules. To simplify them, Jack, put it away. Put it away. Okay? I can't with you guys. You're so ridiculous. Okay. We're gonna use the rules for exponents to generate. What's a smaller, simpler word for generate?
Make.
Create.
Make, good. I'm okay with the word create too, that's good. To make or create equivalent expressions. What does equivalent mean?
Equal to.
The same.
Equal to, what do we break it down? 2 words, we break it down to equal.
Properties. Oh,
Equal
denominator.
is equal, val is
Equivalent.
value.
Oh,
So, equal value expressions. An expression is any number sentence that doesn't have an equal to sign. Like, so just let's go over what the difference between an expression and an equation. 5 plus 3 is an expression. 5 plus 3 equals 8 is an equation. You guys understand that? It's kind of like the difference between a sentence and a phrase. So an expression is like a phrase. The equation is when it's set equal to something that's balanced on both sides.
So basically, the expression is the same thing as an equation, it just doesn't have an equal sign.
An expression always has some sort of operation. Could be addition, could be exponents, like 2 cubed is an expression. It has an operation, but it's not finished. 2 cubed equals 8 is an equation.
That would equal 4.
What?
No, 2 cubed.
Yeah,
2
2 times
cubed.
2.
No.
Cube is 3.
Cubes
Oh.
is 2 times 2 times 2.
I was like,
All right, so this lesson, did I press record?
Yeah.
Okay, I always like, I'm so afraid that I'm gonna get to the end of class and be like, well,
we're
that
6
was
minutes, 20 seconds in.
fake. Listen, so this lesson is weird. And there are gonna be parts that you're gonna not wanna do, okay? There are also gonna be parts that are like, oh, well, didn't we like just do that? Uh-huh. So the first example is kind of like a, didn't we just do that? So we're gonna go through that, it's gonna be simple. The second example is actually 4 different parts, A, B, C, and D. And they're their own, I think they're their own examples. So it's really like doing example 1 and then 4 examples for example 2. So we're gonna work through all of those. We will stop at the end of that and we'll finish the rest tomorrow. Probably starting tomorrow with the try it problems for example 2. All right, so for now, let's go to this simple things, just like a little review. Okay. I'm not gonna go through everything the book says. I think it's a little more complicated than it needs to be. I just want everybody to be reminded of what these rational exponents actually mean in terms of radicals. What do I mean by a radical?
I mean, the same.
Nope. Radical.
Oh, like a radical sign.
Yeah, what's a radical sign?
It's like where it goes like.
Oh,
the
it's
line
like
and
the house thing.
Oh yeah, the ding ding ding.
Can I
ding.
draw
oh,
it?
the square?
It's like the division.
No, it's the it's
Can I
the
draw
it's
it?
the V
Can I
and then it
draw
goes
it?
up and then it goes.
You spit out your gun.
Can I draw it?
I'm not
Sure.
Oh, I see where you're going.
Draw it right here.
Good job. Come on, brother. Yeah.
That's so good.
Also, I heard that.
You don't, it doesn't have to have this fancy like flappy thing
That's what I was
on it. Well, that's wonderful. You went to a very fancy school
No, I
last
got
year.
told by my dad.
Oh, okay, a very fancy father. Okay, so we call this is a radical or a square root sign, right? Now, it's called a square root sign if there is no index here, if there's no number. Because the invisible number that's here is what? Nope.
0.
This is like the only time when the invisible number is not 1, it's 2. Very
Oh,
good.
yeah, that's right. Okay.
Thank you.
Yeah.
So if we have 3 to the half power, the denominator,
Yes. You're welcome. Bye, Lex.
Wait, wait, Lex, you're actually going home this time.
I am actually. You can tell me.
I won't be here.
Go to the back. This is a big one.
Bye, Lex.
Bye, Lex.
No.
Like a slice of
Right.
pizza.
Oh my God.
So,
Yeah, for you.
I volunteer.
Love
I
how it
volunteered
right.
and everything.
That was so nice of her to ask. Okay. I probably would take it if I was like not in
Not-
the
yeah,
class
yeah.
right now.
Save it for later.
Shh, it's okay. He's just like, I'll just ugly put your mom. Just kidding. All right, so 3 to the half power can be translated, rewritten as a radical, the square root of 3. When the denominator is 2, that means your root is 2. And if your root is 2, you technically do not have to show it. That's the only time that the invisible number isn't 1. Now, if we had something, go ahead. Why so many?
Oh, I didn't mean to take that many.
Why are you taking 2?
Oh, because I know I'm about to run out of lead.
How about just 1?
Okay.
How can you tell that you're about to run out of lead?
When I shoot it, I only heard one piece.
Okay. We need to refocus because we're stealing learning time now, okay?
I apologize.
Okay, so 3 to the half power equals the square root of 3. Do you guys understand that? Let's try something a little more complicated. Let's do 4 to the 2/3 power.
Wait, wouldn't 3 be in the outside?
Yep,
2 be
3 is our little index here, our root. And then 2, our numerator, is our exponent. So the denominator is the index, or the root, and then the numerator is the exponent. Have we done this? Yes, this was part of one of our exponent properties. We went through all of this. This example is just kind of reviewing that. All right, I'm gonna move on, okay?
Is that just how you solve it? Nothing else?
Yeah, we're not solving anything, we're just rewriting it. So all it says here is we're going to define 3 to the half power to be the square root of 3.
So the denominator goes on the outside?
Yes, the denominator is what's called the index or the root. And I'm just going to go to the example 2 now. We don't need to do the try problems. Okay, here we're going to do A, B, C, and D. They're going to be like 4 examples in one. We're going to work through them one at a time.
I found this broken.
I know it. I've had to come over to it several times. The next time is going to be, okay. So what we're going to do is use the properties of exponents, all of our rules, everything that we've learned, our little tools in our toolbox, to generate an expression, make an expression that is equivalent to this. We're basically going to simplify it. So I'm going to put it over here. 1 over 125. Gonna write it exactly as they do it, but do not pay attention to this, okay? It's weird and I don't like it, so we're gonna make it simpler than that. To the negative 1/3 power. Before we touch that, let's go over here. And let's review something that we did when we were doing our properties. And we had an example that was this. A over b to the negative n power, n just representing any digit, okay? What did we have to do when we had that?
We distributed it to both, but we made b go to the top because since it's
And we
negative,
made b go to the top
and we made a go to the bottom since
yes.
a has negative.
And what did we call that?
Flippies!
Flippies! Flippies! So when you have a quotient, which basically means your fraction or division problem, boys in the back.
Sorry.
When you have a quotient, a division problem, a fraction, where the whole thing is being raised to a negative exponent, that means they both have a negative attitude and they need to do flippies. You go to the dungeon. You go up to your room. Fix that attitude. Make it more positive. Okay? So all we're going to do is do flippies. The b goes upstairs, the a goes downstairs, and now it's raised to the positive n power. And then we would continue to simplify from there if there were anything left to do. It would be b to the n power over a to the n power.
I would say like one of them it'd be that.
Yep. Yes, Faith?
Instead of it being like 1 and then the 0 and power and that, classes to separate, they work separate rooms.
Oh, okay. Yeah, it's just basically like, go, get out of here, right? All right, so using this property, this rule, if something is being raised to the negative anything power, Jocelyn, what do we do? What? You gotta say it like with a special word.
You got this, Jocelyn.
Ready? 1, 2, 3.
Flippy!
Flippies! Okay. So
So
this is going to become 125 over 1 to the positive 1/3 power. Flippies!
25.
Hooray.
Exactly. Then, when you look inside that fraction now, that can just be simplified inside to 125. Not 125 over 1. We don't need that noise in our life anymore. Yeah.
So when the exponent is negative, you flip the actual fraction and not like the fraction of the exponent?
Yeah. Yeah, this has got to stay intact, just the way it is. The negative attitude will change after after the base does flip.
like think of it like this.
Yes,
But why doesn't the actual thing do flippies?
because that would be insane. I'm just kidding. It just doesn't. I only have a few minutes to get through these. Grayson?
Yeah, for the 125, when you reduce it just to like 125, would the exponent fractions stay the same and go with the
Yep,
125?
exactly. I'm gonna simplify it down here. So 125 over 1 is simply 125. And that is being raised to the 1/3 power. Don't really need these parentheses anymore, but I just put them there for fun. So 125 to the 1/3 power, let's rewrite that as a root. Yay! Okay, that was quick. We were just really excited that you came back. That's all. Okay, attention here. We're gonna rewrite this as a root. How do we rewrite it as a root? Yes.
You put the 3 on the outside.
You put the 3 on the outside.
They used to do 125.
The cubed root of 125.
You're yapping about it.
I'm getting jazzy.
5.
Did you these
Is it
radicals are
five?
making me
Is it
jazzy?
five?
This is late. Did you hear what Bo just?
I didn't, I'm gonna ignore it. Never mind.
Isn't it 5?
It is 5, and we can plug that into our calculator. Let's go over how to do that. How to plug that into our calculator, okay? Everybody pick up your calculator.
I'm trying to do
Make sure you have a calculator. Charlotte, can you pass around some calculator?
Oh, that's what the calculators
We're
are.
gonna make sure that we know how to do this, because that's important, right? Natalie needs one vote. Can you give one to Natalie? Do you have one, Lily? So do you want to get one too, or do you not want to do this?
Oh, I forgot about you.
It's really, we get to press buttons. First we're doing flippies, we're pressing buttons. It's so much fun in algebra class.
Yeah.
Yeah!
You have to do
That's
this.
my story and I'm sticking to it. Everybody have their buttons?
Yes.
Okay, it's time to press buttons, okay? You know when you're a kid and you get in the elevator, you're like, hey, press the button. We get to press the buttons today. Okay. So, this is how you do it. This is how you do it.
No, ruined it. Oh, that's just an email.
Dear Bo's mother.
Almost across the state.
Dear Bo's guardian. Okay,
It's un pop.
here we go. So we're gonna type in 125.
Okay.
Now, the root function is a second function. It's this little baby writing above the y to the x power button. So we will end up pressing this button, but since we want the second function, that little thing above it that says the x root of y, we have to hit the second function button. Then we hit the button that says y to the x power. Even though we're not doing exponents, we're doing the root above it. Then you have to type in what your root is, which is 3.
I got 5.
Then you get
0.
5.
23.
Good job. Everybody show me that you got 5.
1, 2, 3, that, 3.
Are you okay, Lily? Oh, okay. have water in there?
Miss Light,
Yeah?
it's not working for me.
It's not?
See, look, I just went to 5, I pressed the Y.
Nope.
You gotta go to the second function.
The second function first. 125, second function. Then the y to the x power button, which is not the actual function that we want, but the one above it. Then you put in 3 for your root. 5.
So what?
So second function, and then this button right here, because we want this up.
Function.
Second function is here. So here, and then this, and then type in 3. No, you have to type in 3. Oh wait, you started it over. Okay, so 125, second function. We want this little guy right up here between the off, but yeah, right here. And then we put in our root, and then equals and equals 5.
That's gonna make life so much easier.
There's also a cube function right here.
What? There's a cubed root button?
Where?
I totally knew that.
Nice.
Okay, let's try that again. 125, second function, cube root. Boom! Skip a step.
Cube root button. Oh wait,
I did it.
I found it.
No, you didn't.
What?
I got error.
I got error.
Okay. Step 1.
Hey, throw up the calculator.
When a quotient, which basically means a fraction, is being raised to a negative power, what do? Flippies!
Why are we so excited by saying flippy?
I don't know why, it's a fun word to say. It's a fun word to spell too. This is how I spell flippies.
With a Z? That's not
That's
with
fast.
an S.
That makes the exponent positive. I still have a ton to get through. I want absolutely no talking to the end of class, okay? It's gonna get really serious real quick. That makes the exponent positive after you do flippies, okay? Then, the exponent belongs. Actually, I'm not gonna write that because we didn't have to do that for this one. That'll be confusing. Let's see, is there anything I need to say? Then just simplify. I'm gonna make it general because if I get too specific, it won't apply to other problems. It will only apply to this problem. So I'm just gonna say simplify for that. Okay, ready for the next one? I still have 3 more examples to do. B, C, and D.
And how much time?
Okay. We're not talking, we're not making any noise. You need to be writing what I'm writing, okay? Okay, so this is about to get crazy. You're gonna freak out when you see this.
Crazy.
I'm gonna prove to you that 8 to the half power is equal to 16 to the 3/8 power.
Yeah.
I'm gonna prove it. I'm gonna prove it
That's
so hard.
Are you a mindist?
No more talking.
I'm sorry.
No more sounds. I don't have to be silly. I can just be extremely serious and do it that way because that will keep out the that will keep out the extra comments. Okay. Now, I do know that 8 to the half power also means the square root of 8. So if I put in the square root of 8, let's just see if that makes things simpler. 8 and then the square root, oh good, I got 2.828427125. That's a little complicated, it's gonna keep going and going and going. So I'm not gonna really be able to prove that they're equivalent to each other by doing the calculator. I'm gonna have to figure out another way. Let me show you the way. I'm going to rewrite the base 8 and the base 16. I'm gonna do this. Rewrite with a base and power. So, I'm gonna rewrite the 8 here. I'm still gonna raise it to the half power, but I'm gonna rewrite it so that it's no longer an 8, but that it's a base and a power that's equal to 8. Can you think of what base and power that would be, Bob?
8/1.
No, a base and a power, Jacob.
2 to the 3rd.
2 to the 3rd, very good. Sorry, I pointed at Carmine and said Jacob, it's very confusing, no talking. Here we go. 2 to the 3rd power. Do you agree that I'm allowed to write 8 as 2 cubed if I want to, because it's the same
Yes.
thing?
Yes.
Okay, why would I want to do that? I'm gonna rewrite 16 as a base and a power. There are 2 options. Name
Four
both
cubed.
of them.
4 to the 4th.
4 cubed,
Yeah, so like
not 4 cubed.
No.
4 to the
4 to the 4th.
4 squared.
No, 4 squared.
Oh,
4
squared.
squared.
Sorry, that's what I meant.
So this could be 4 squared or
2 to the 4th.
2 to the 4th. Take a wild guess at which one we want to use.
2 to the 4th.
That one.
2 to the 4th. Because we're trying to get them to look alike, right? So I'm going to choose the expression 2 to the 4th. And of course I still need to raise it to 3 to the 8th, because I have to keep everything
The same.
the same. Now they still don't look exactly the same. I have the same 2's over here, but then, wait, if a power is raised to a power, can I do something with my exponents?
Yeah.
Like, what do I do?
Multiply.
Yeah, like multiply them. So 3 over 1 times 1/2 is simply
Please.
3 over 10.
What just-
Why that bleh?
And then I'm gonna do the same thing like over here.
Is this the 80th or something?
I don't know what it is. It's just, I'm just going with it. So 4 over 1 times 3 over 8, I'm gonna do canceling to reduce before I multiply because it's easier. 1 times 3 is 3. Oh, I got another 3 over 2. Oh my gosh.
We did
This
it.
is exactly the same as this. It's like looking in the mirror. So I just proved that this is equivalent to this because this equals this and this equals this, so they equal
That.
each other.
No matter.
We still have 2 more. Still have 2 more. Oh, you're gonna love this one. You're gonna love it so much. You're gonna hate it.
No, I don't like it anymore.
Okay.
Yo.
Calm down.
Oh, okay.
Calm down.
Okay. Actually, before we move on, let me write down some like quick word notes, okay? What was the first thing we, I wrote it here. We rewrite with a base and a power. You can even say rewrite the base. Rewrite each base with a base and a power. Then simplify. Step 2 would be to multiply your exponents.
So we're taking something like not complicated and making it complicated?
Yep, isn't it fun? Yeah.
Yes.
Whatever, yeah. Whatever helps you sleep at night. Okay, speaking of things that are not complicated at all, not even a little tiny bit, it's so complicated that I can't even see it. So I'm gonna write it bigger, okay? So we have 9a squared. I'm gonna go fast, so pay attention, no noise. C to the -2 over 12ab -3c to the 4th to the -2nd power. Don't copy what the book has. I'm doing it slightly different because I don't like what they did. It's stupid and I hate it. Just kidding. It's okay. But we're gonna do it a little bit simpler here, okay? The first thing that we're gonna do is
Something.
References.
flippies, except that we're not gonna do it first. We're gonna do it second.
Oh.
And the reason we're gonna do flippies as the second step is because inside these parentheses, there's a lot to take care of, right? Let's simplify,
Yeah.
right? Some things will get eliminated. I know something that's gonna get eliminated. What's gonna get eliminated?
The B.
Yeah, the B. Yep, those are gonna get eliminated because that's the same thing, so that equals 1. And then we have got 9 over 12, we can just reduce that fraction, right? So that would be 3 over 4. And then a squared over a would be what?
That
A to
one.
third.
Nope. What do we do when we're
Okay.
dividing?
A.
It would just be a, because 2 minus 1 is 1. A to the 1 is a. So that would sit up top in the numerator. Remember when we are dividing our bases, everything, the result goes in the numerator. And then you can take care of it if it is a negative exponent by sending it to the other place. Okay. And then we have c to the negative 2 over c to the 4. I'm going to write that out here. C to the negative 2 minus positive 4. Kill the cockroach, change the sign. That would be
Wait, no, you
negative
don't.
6.
No, the 4 is positive, so you don't do that.
Kill the cockroach, change the sign to negative. Because of what? The 4 is positive, so I have to change. Kill the cockroach and then change the positive to a negative. Right?
Sure.
Okay, so negative 2 plus negative 4 is negative 6. So that technically belongs in our numerator, c to the negative 6, right? It does, it belongs in the numerator, because the result always goes in the numerator, but if it's negative, you can send it downstairs to make it positive, okay? So we can send the c downstairs to make it positive. Everything is as simple as we can make it. We just have to still show that it's being raised to the negative 2 power. Now it's time for
Flippies.
flippies. So we're gonna do flippies, and then we're gonna do 4c to the 6 on the top, 3a on the bottom, and I'm still gonna put in parentheses and raise it to the second power. Because we did flippies to get rid of the negative, but we still have to raise it to the second power. If everything is raised to the second power, that means everything is raised to the second power. 4 is raised to the second power. C to the 6 is raised to the second power. 3 is raised to the second power. And A is raised to the second power. I know. I know.
Oh my god, that's a lot of.
Oh my gosh.
That's a big thing.
Okay. So we have 4 to the second power is what?
16.
16. C to the 6th to the second power is
12.
what? C to the 12th. Very good.
Okay, that
And
is
3 to the second power is what?
9.
9. A to the second power is. Now, if you wanted to write out like the in-between steps for that and write out like 4 squared c to the 6th squared over 3 squared and then a squared, totally fine. We kind of did that out loud and we ended up with our result. Can that be reduced or simplified at all?
Not that I know.
No.
Nope, 16 over 9's got to stay that way, and then
That's the
can't do
answer.
anything with those exponents, so I have one more thing to show you. That is the answer. Okay, you ready? I'm just going to erase on this side. All right, I'm on fire. Let's go. One more. Of course it's going to be harder. They get harder and harder every time. That's the fun of algebra.
That's the least.
If it got easier, it would just be too boring. All right. Oh, I can't even, okay. Don't worry about what it says because, oh, you know what? I actually don't like that they use a negative here because it's stupid and I hate it. So I'm going to use a positive 8 because the negative is just making it uglier. And we'll use a negative when we are doing practice problems. This one, I'm just going to use a positive 8. And then I'm going to write what they have. 3t plus 2 is our exponent. What? We have an expression as our exponent. An expression that involves addition and multiplication. Keep that in mind. This expression that our exponent is involves addition and multiplication. What is it?
Does that mean you do the parentheses first now?
I mean, no, because 3t plus 2 cannot be simplified at all. On its own, 3t plus 2 is 3t plus 2. We can't combine terms, we can't do anything. Anyway, so, I mean, if you can figure out something to do with that, then you always do it, okay? You getting this done? All right, but keep that in mind, that we have base that is being raised to an exponent where there are two things going on. It has addends, 3t is being added with 2, And also 3 and t are being multiplied. So let's notice the addition part first, okay? Isn't there a rule with exponents where you end up having to add the exponents? It's like a, if this blah blah blah, then add the exponents. What's the blah blah blah?
Oh, you like have to separate like the things being added.
If the exponents have the same base,
Yes.
then you add them together.
If exponents have the same
I think
base
it's just-
and they're being multiplied together, then add the exponents and you'll figure it out. Uh-huh. Okay, so they kind of already did that. So we're gonna break it back down. We're gonna go in reverse. Okay, reverse, 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 reverse. Okay? So I'm gonna rewrite this as 8 to the 3t power times 8 squared.
That's a lot of squares.
Yeah, but because I was able to separate them now, I can actually simplify this part. I couldn't simplify anything before, but when I broke it up, I can square the 8. If anybody packs up, oh, we're not even close. We have so much time. 8 squared is what?
54.
64. Boom, simplified. So it's gonna be 64 times whatever this is. I can go even further. Tom Martin is calling me like I have time for you. 8 to the 3t power. Wait a second.
What?
Didn't we learn about a rule where you end up having to multiply your exponents?
Already.
And the 3 and the t ended up being multiplied together. But what happened before that?
I don't know.
Jacob, do you know? What is happening that causes exponents to be multiplied? Yeah.
Because it's an exponent.
No.
It's 8 times 8 times 8.
It's when the exponents. It's when the exponent is the exponent.
Yes, I love how you use my fake terms. Yes. The real terminology is power to a power, but my fake terminology is when an exponent is being exponented. So we know that if a base has a power, then is being raised to a power, they get multiplied together. But that means that 8 to the 3rd power was raised to the t power, right? Because you can multiply these exponents. 3 times t is 3t, and it would simplify to that. So we're unsimplifying it so that we can separate the 3 and the t, and now simplify the 8 cubed. What's 8 cubed?
512.
512. You can look at it on the board, you can do it on your calculator. 512 to the t power
So 512.
times 64, and that's all we can do.
Oh yeah.
Wait,
Yeah.
we can't multiply it by
No.
So if you want to like write it in a a very fancy way, we would just write the 60. This is a totally correct way of doing it. I would just write 64, and then I would show that it's being multiplied times 512 to the peak tower. Now somebody tell me right now why we can't multiply these numbers. Why am I saying that that's as far as we can go? Grayson.
Because there's an exponent with a t and the other one doesn't have a t, so we can't multiply them together because it's an exponent.
Oh, I know.
You're kind of like in the same country as the answer.
I have a really good answer.
Okay.
How about you?
Mariah.
One of them before they kill themselves.
Not because the exponent. Well, you might be on the right track, Carmine.
So you go left to right when
No.
you solve a pen
If I go left to right, then I would be able to multiply these.
No, right to left.
Well,
Okay, so okay, so basically, like you have the exponent to anything in it, so they can't combine because it would be 512 to the power to t, and then after that, since they're not like a like terms, then you can't combine them.
yeah, I think you. Yeah, can you say it? Like, can you translate for
Why
both?
don't you like actually to actually finish the problem when you go to the street, and then after when you
Yeah.
So So I think you guys are all like in the same country as the answer. Are you throwing things at me now?
Yeah.
That's a suspenseful.
Get out of the
Hello?
closet.
Hello? I need security. I'm being abused. Okay. Carmine, do you have something to say?
Yeah, I was basically gonna say that it's kind of like we're like you have 15A plus 15B
I know.
situation.
I know.
No. Angelina, tell me.
I
I'm looking for a specific phrase
know how to word it better.
to tell me why I cannot
No, I can.
multiply these. It's 3 words. The middle word is tiny.
What?
Jacob. Okay.
No, you got it wrong.
Say I don't even know.
Okay, well,
It's not 3 words, but here's what happens. Basically, you multiply the 512 next to the t, so it's 512t.
why do we have to do that first? Is there some sort of order?
Oh my god!
Order of operation
Operation.
tells us that we have to do exponents first and then multiply. Since we can't actually bring anything to the t power because we don't know what t is yet, then we can't multiply. If somebody said, oh, t equals 2, then we could do that and then multiply them, but we have to follow order of operations. Therefore, this is the answer as simple as we can get it as it is. We got everything done. If you could end the video and you guys can back up.